to your inbox within a period of 5 minutes. After the session, the room will not close. Instead, this room will turn into a call center. We'll be there to help you out with your certificate. So in case you do not receive your certificate of participation in your inbox, you can share your email ID with all the panelists, and we will be helping you with your certificate of participation. But one help that we need from your side is that you should fill and submit the feedback form successfully. My co-coordinator, Ms. Ayushi, has also joined us. Good evening, ma'am. Welcome to the session.
Good evening, ma'am. Good evening. I hope I am audible.
Yes, ma'am. Perfectly.
Thank you. Thank you so much. A very pleasant good evening to all the panelists and participants connected with us. It is a pleasure to connect with you all. I welcome you all for today's session on the topic machine learning, algorithms, and behavior of data. Our expert for today's session is Professor Swagatam Das. Swagatam Das, sir, will join us shortly. So dear participants, this is for your information that the recorded video of this session shall be available on our YouTube channel at the earliest by the end of this session. The details of our YouTube channel will be shared on the chat window. I would also request you, dear participants, to please check that whatever device you are connected with, you can access your chat window. Dear participants, it is also to inform you that kindly ensure that whatever device you are connected with, you can access the chat window, as the chat window is an important mechanism through which we all will be communicating during this webinar. So any questions you will be having, you can write us on the chat window. I shall be facilitating the same by asking those questions, but at the end of this session. I also request you, dear participants, that we will be sharing a feedback form link on the chat window for automated generation of the certificate of participation for today's session. Dear participants, kindly ensure that you are connected with us till the last of this session and you own yourself a certificate of participation of this session, despite increasing your knowledge. A very pleasant evening to all the panelists and participants connected with us. It is a pleasure to connect with you all. I welcome you all for today's session on the topic machine learning, algorithms, and behavior of data. Our expert for today's session is Professor Swagatam Das, sir. Swagatam Das, sir, will join us shortly and we'll be beginning with our session.
Ma'am, Swagatam sir has already joined us. A very good evening and a warm welcome to the session, Swagatam sir.
Good evening, sir. Swagatam, sir. Very warm welcome.
Hope I am audible to all of you.
Yes, sir. Perfectly.
Thank you.
So we will be giving the sharing rights to you. We'll be making you the presenter. So then you can share your slides and you can check that also.
Sure.
Uttam sir, we can make Swagatam sir the presenter. Sir, you already have the presentation rights. Along with the video option, you will see a share option over there.
Yes, I can see it. That's fine.
Yes, sir. Professor Subramaniam Krishnamurthy has also joined us. Good evening, sir. Welcome to the webinar.
Good evening, ma'am. Thank you.
Thank you, sir.
Welcome, Subramaniam, sir. I welcome Swagatam Das, sir. Harjinder Singh, sir. I welcome all the panelists, respected panelists to this webinar, and my dear participants. I welcome you all.
Our Honorable Director, sir, Professor Emin Huda, sir, has also joined us. Good evening, sir. Welcome to the session. So, dear participants, in a while from now, we shall be beginning with today's webinar. Swagatam, sir, if you want to check, you can share your PPT and check it before we begin.
Yes, sure.
Yes, sir. Yes, sir. It is perfectly visible.
Can you see the full screen of it?
Yes, sir. I can see the full screen and the color contrast, etc. Everything is perfect.
Thank you.
You
Very
can
good.
see the next slide also.
Oh,
Thank you, sir.
Thank you, sir. So a very warm and pleasant evening to all the panelists and participants connected with us. It is a pleasure to connect with you all, dear participants and respected panelists. I welcome you all for today's session on the topic Machine Learning, Algorithms and Behavior of Data. Our expert for today's session, Professor Swagatam Dasa, has already joined us. We'll be starting soon. So this is for your information, dear participants, that the recorded video of this session shall be available on our YouTube channel at the earliest possible by the end of this session. The details of our YouTube channel will be shared on the chat window. Further, I would like to request you that you can kindly ensure that you can access your chat window. Whatever device you are connected through for today's webinar, kindly ensure that you all can access the chat window, as chat window is an important mechanism through which we will be communicating for this webinar. So any queries, any questions you will be having, you can write us on the chat window. I shall be facilitating the same by asking those questions, but at the end of this session. I also request all the participants that we will be sharing a feedback form link on the chat window for automated generation of the certificate for today's session. Dear participants, kindly ensure that you are connected with us till the end of the session and own yourself a certificate of participation for this session.
Dear participants, our Honorable Director, sir, Professor M.N. Huda, sir, has also joined us. Good evening, sir. Welcome to the session.
Good evening, Dr. Ritika. Good evening, Ayushi. And good
Evening,
evening,
sir.
Bhatia, sir. Good evening, Krishnamurthy, sir.
Good evening to everybody.
Yeah,
Sir,
good
Professor
evening.
Swagatam Das is also with us.
Oh, great.
We'll have Swagatam now for him.
Yeah, good evening, Professor Swagatam. Good evening. So, welcome you for the program of IEEE and BBICAM webinar series. Dr. Ritika, where is my friend, Professor Panigadi?
Sir, we are awaiting Professor
Oh, we are
Panigadi.
He is
waiting.
taking Pani Puri now.
Okay, yes.
good evening, Professor Huda. Thank you very much.
Let me check Professor Panigadi.
Yes, sir.
Yeah.
So a very good evening and a very warm welcome, all dear participants. We are all set for today's webinar. In a while from now, we shall be beginning with today's session on machine learning and the role of data.
A very pleasant evening to all the panelists and participants who all have connected with us. It is our pleasure to connect with you all. I welcome you all for today's session on the topic Machine Learning, Algorithms and Behavior of Data. The expert speaker for today's session is Professor Swagatam Das sir. Das sir has already joined us. We'll be starting soon. Before starting, I would like to brief you. Dear participants, kindly ensure that whatever device you are connected with for today's session, kindly ensure that you can access the chat window from the same, as it is an important mechanism through which we all will be communicating during this webinar. So any questions you will be having, you can write us on the chat window. I shall be facilitating the same by asking those questions, but at the end of the session. Also, dear participants, we'll be sharing a feedback form link on the chat window for automated generation of certificate of participation for today's session. So dear participants, kindly ensure that you are connected with us till the last of this session and own yourself a certificate of participation. We'll be starting with today's session in a while. A very pleasant evening to all the panelists and participants connected with us. It is our pleasure, and I thank you all for connecting with us. I welcome you all for today's session on the topic Machine Learning, Algorithms and Behavior of Data. Our expert speaker for today's session is Professor Swagatam Das, sir. Professor Swagatam Das, sir, has already joined us. We'll be starting soon. Dear participants, it is also to inform you that the recorded video of this session shall be available on our YouTube channel at the earliest by the end of this session. The details of our YouTube channel will be shared on the chat window. I would like to request you that please check that you can access your chat window for a smooth mechanism all through the webinar. Also, please keep on checking the chat window for further information.
Dear participants, in a while from now, we shall be beginning with today's session. Meanwhile, I request all of you to kindly ensure that you can access the chat window on your device. The chat window is an important mechanism through which we shall be communicating throughout this webinar. Any questions you have from expert for today's session, you can keep writing the same on the chat window. We shall ensure that we ask them with our expert at the end of today's session. Further, a feedback link for your certificate of participation generation for today's session will also be shared in the chat window towards the end of today's session. So in a while from now, we shall be beginning with today's session.
I have spoken to Professor Panigari. He is just joining.
Yes, sir.
And
Okay.
good evening, participants. We are about to start it. Meanwhile, you may keep writing your name and your city, name, affiliation, and your city in the chat window for our information. And if you have not joined our forthcoming webinar, I think 5 of them have already been notified. Please click on the registration page and join it. Also, if you are not member of any of our WhatsApp group, you must be joining any of the WhatsApp group because most of the information is being shared in a handy manner through our WhatsApp group. Good to have participants from different parts of the country.
So today we have participants from all across the globe.
Yeah, that's great.
Professor Subrata sir has also joined us. Good evening, sir. I welcome you for today's session. Very warm welcome, sir.
Okay, good evening to everybody.
Subrata sir, good evening.
Good evening, good evening.
The today topic is very important. Our speaker is very expert in its domain, so it is bound to fetch participation from all parts of the country and outside the country.
Okay, already it is 305. I could see it with panelists.
Yes, sir. Yes, sir. Yes, sir. And I can see participation right from the east, Jamshedpur, Bengal, Orissa, and of course, UP, Bihar is there, Bengal is there, and then Chandigarh, Kashmir, then Chennai, and Tamil Nadu, other cities of the Tamil Nadu, Kerala, Maharashtra. Oh, yes, great. So, Ayushi?
Yes, sir.
Professor Panigari is here? No.
No, sir. Here.
Let me just one minute again inquire him, then we'll start. Just a minute.
Yes, sir. So dear participants, we are all set, and in a while from now, we shall be beginning for today's webinar. Dear participants, chat window is the same window where you are writing your messages at the moment. You're sharing your affiliations with us. I repeat, this chat window is important because during the session, if you have any questions from our expert, you can keep writing on the chat window. Professor B.K. Panigrahi from IIT Delhi has also joined us. So welcome to the session. I hope I am audible, sir. Panigiri sir, welcome to the session today. Sir, you are on mute, so we are not able to hear you.
ये उत्तम प्रोफेसर पानीगढ़ी ने गलती से अटेंडी में ज्वाइन किया है, उनके राइट्स चेंज करो जरा देखो.
Sir, he is in
Uttam?
panelist also from his mobile.
But
a double
usually I
entry.
can't. Yeah, now he's here. Professor
Yes, sir.
Panigari, can you hear us? Can you unmute and just speak?
Yes. Now
Oh,
I'm
yes,
able
great.
to hear and
Great.
yes.
Great.
Yeah.
So we have all dignitaries available. Ayushi, we may start, please.
Okay, sir. So a very pleasant evening to all the distinguished panelists and participants. Bharati Vidyapeeth Institute of Computer Applications and Management in association with Computer Science chapter of IEEE Delhi section, Consultants Network Affinity group of IEEE Delhi section, Life Member Affinity group of IEEE Delhi section, Inter-Society Relations Standing Committee of IEEE Delhi section, Industry Relations and Side Standing Committees of IEEE Delhi section with the associations CSI, Institute of Information Technology Professionals, IITP, ISTE Delhi section, IETE Delhi Center and IEEE Communication Society Delhi chapter as technical collaborator welcomes you all to the webinar on the topic Machine Learning, Algorithms and Behavior of Data. It is a moment of pride and honor to announce that we, with united hands, marks special contribution for the monumental occasion Azadi Ka Amrit Mahotsav, an initiative to celebrate 75 years of glorious independence by organizing the thought-provoking sessions for better future. This webinar is an initiative for celebration of Azadi Ka Amrit Mahotsav. Much of what we do with machine learning happens beneath the surface. Machine learning drives our algorithms for demand forecasting, product search ranking, product and deals recommendations, merchandising placements, fraud detection, translations, and much more. Though less visible, much of the impact of machine learning will be of this type, quietly but meaningfully improving core operations. Very well quoted by Jeff Bezos. In the current age of fourth industrial revolution, the digital world has built of data such as Internet of Things data, cyber security data, mobile data, business data, social media data, health data, etc. To intelligently analyze these data and develop the corresponding smart and automated applications, the knowledge of artificial intelligence, particularly machine learning, is the key. The webinar aims to discuss the comprehensive view of machine learning algorithms that can be applied to enhance the intelligence and capabilities of the application. I would first take this opportunity to welcome amongst us our distinguished panelists for today's session. We are privileged to have amongst us a galaxy of experts. I welcome Professor Subrata Mukhopadhyay, sir, Chairperson, Consultants Network Affinity Group, and former Chairperson, IEEE Delhi Section. Professor B.K. Panigrahi, Institute Chair Professor and Head, Center for Automotive Research and Tribology, Professor, Department of Electrical Engineering, IIT Delhi. I also welcome Professor M.N. Huda, sir, Director, Bharatiya Vidyapeeth Institute of Computer Applications and Management. I now request Professor Subrata Mukhopadhyay, sir, to commence this session with his welcome address. Please, sir.
Good evening to everybody. Today's webinar, as I see it, it is the machine learning algorithm and behavior of data. So long we were considering mostly artificial intelligence along with this machine language, definitely on different fronts. This time probably we have gone and touched depth into the system with algorithms also, and the data definitely it will cover about compatibility, security and all sorts. I belong to power system area where large data is required even for the real-time system operation. If we are in a position to attempt for the artificial intelligence. Almost for the last 4 or 5 years, we are doing it, and in PS, under PS, number of works have been reported, and even in the real-time system. But again, we use a lot of state estimation. We do not give the exact data what is transmitted from the real-time system. Basically with an idea, because there may be some bad data also, which may jeopardize the security for a large system. And depending on your algorithm, how it takes care of all these things, I'm very sure today's speaker, Swagatam Das, will be dwelling on different types of applications and give details of maybe some of the algorithms which they might have developed and working otherwise globally, and see how it is handling data and giving in real sense an artificial intelligence application with the data available with the system. With this, over to Ayushi.
Thank you so much, sir. Thank you. It gives me immense pleasure to request Professor B.K. Panigrahi, Institute Chair Professor and Head, Center for Automotive Research and Tribology, Professor, Department of Electrical Engineering, IIT Delhi, to please share words of motivation. Please, sir.
Yeah, very good evening to Professor Mukhopadhyay, Professor Huda, and all the dignitaries. And good evening to my one of the best friend, Professor Swagatam Das, who agreed to give the talk on this. So this is actually very interesting because we are playing with a lot of data, as Professor Subrat Mukhopadhyay has told, whether it is a power system or any type of system or medical system. So now the question is, you have to look into the type of the data which you are going to handle. So we don't know from which date we have entered from the small data to big data. So nowadays everybody is talking of this big data analytics. So let me introduce Professor Swagatam Das here because he's a very young, dynamic researcher of only 42 years of age. And we know each other from 2007. And to his credit, he is one of the associate editor of IEEE Transaction Evolutionary Computation. He was also associate editor of various IEEE journals like System, Cybernetics, all those things. And is the chief editor of one of the very prestigious journal in Elsevier Science, that is Swarm and Evolutionary Computation. So let me highlight here, Professor Das started his research from this evolutionary computing. He rose to the peak while he was in Jadavpur University. Then he switched over to ISI Kolkata. Then immediately he switched over looking into the need into the machine learning and mathematical aspects of the machine learning. So he gave a lot of thrust into the mathematics without applying all those tools and techniques. So welcome, Professor Swagatam Das, and I hope all these panelists, all these who are attending this, including me, will learn a lot of things, because this is a challenge nowadays, how to handle all those data, looking into the imbalanced data set, looking into the volume of the data set. So welcome, Professor Das, and Ayushi, please.
Thank you so much, sir. Thank you. Good to have you here with us, sir. I now request Professor M.N. Huda, sir, Director, Bharatiya Vidyapeeth Institute of Computer Applications and Management, to address the participants with his inspiring words. Please, sir.
Good evening, one and all. Am I audible, Ayushi?
Yes, sir.
At the outset, let me welcome today's valued speaker, Dr. Swagatam Das. Thank you so much, sir, for having accepted our request. In fact, the credit goes to my friend, Professor Panigrahi. I also take this opportunity to welcome and pay my gratitude to all my friends from various professional societies, Professor Subrata Mukhopadhyay, who has been the main force behind running this series under collaboration with IEEE and BVI-CAM, this webinar series. My friend, Professor Panigrahi, from IEEE Computational Intelligence Society, CIS, and then Professor Krishnamurthy, Subramaniam Krishnamurthy, the former chairperson of IEEE Delhi section, my friend and a National Governing Council member of IET, Professor Bhatia, and many other friends as part of even the attendees, and finally the participants from all parts of the country and abroad. I could see, including YouTube Live, close to 400 plus people are attending it. Today's webinar, which is again the part of the same series, IEEE, BVI-CAM, evening weekly webinar series. This is 65th of that. And the topic today, which has been decided, was machine learning and machine learning algorithms and behavior of data. The introductory talks related to that has already been given to you by the anchor Ayushi, Professor Mukhopadhyay, and one of the known experts of this domain, Professor Panigari. My dear friends, it is said that the next war will probably on data. Forget about this Ukraine. But machine learning is such an important topic that if we see last almost 50 years since 1956 when AI concept was coined by John McCarthy, after that one of the best application of artificial intelligence is the machine learning. My prior friends have already given you a brief idea that how machine learning is transforming our engineering sciences and day-to-day applications. The application of machine learning is not limited to only the engineering sciences or maybe hardcore medical sciences. It has spanned through almost all disciplines of day-to-day affairs. And that's how we say that not only hardcore engineering or hardcore medical domain is also important. This machine learning is also important because it gives enterprises a view of trends in customer behavior and customer operational patterns. You might have seen about predictive analytics and descriptive analytics, etc., etc. And at the same moment, it also supports the development of a new product, means that enables the organizations to take a strategic decision. That's a kind of value of this machine learning. Many of today's leading companies in the world, such as Facebook, Google, Uber, and Amazon, etc., etc., are making extensive use of machine learning in their entire business operations. And that's how we have decided that this topic is very significant, which is going to give a competitive advantage not only to the companies, not only to the organizations, but also to we all researchers, also to we all teachers, also to all peer friends. And that's how this topic was finally decided, and Dr. Swagatam Das, one of the top researcher of the domain, was requested to enlighten us, to give us detail, to make us to understand the fundamentals of particularly the hardcore algorithmic aspect. Maybe today's talk may be a little mathematical, but that is required to understand the applications of the mathematical modeling with respect to machine learning, and I'm sure every one of us will get benefited out of that. I also wanted to mention that 2022 is a very auspicious year in terms of 75th anniversary of the glorious independence of the country. So now onwards, all the webinar will also be adding a feather. In all the webinars, another feather will be added in the cap that it is under the banner of Azadi Ka Amrit Mahotsav. So it is under 75th anniversary celebrations of our independence. Thank you so much for joining from different parts of the country and abroad. Keep joining our program, because last June 2020, in the backdrop of COVID-19 first phase, when we started, we decided that let's engage peer professionals from different walks of life all across the globe to engage themselves to ensure that they continue to learn despite disruptions all around us. That was our objective, and since that June 2020, we are continuing with the same momentum, with the same zeal, with the same objective, that यही है जुनून मेरा, यही है शौक मेरा, यही है जुनून मेरा, यही है शौक मेरा, चिराग वहां जला दें जहां है अंधेरा। तो हम इसी चिराग को जलाने की कोशिश कर रहे। और मशीन लर्निंग या एआई टेक्नोलॉजीज तो ऐसी टेक्नोलॉजी है जिसके बारे में मैं हमेशा ये कहा करता हूं कि मे बी अ डिकेड डाउन द लाइन we may see applications which possibly may be beyond our understanding, beyond our imaginations as well, at least beyond the imagination of a normal human being. And that's how a poet has expressed these kind of applications, which sometimes becomes the beyond the imagination of human being or ordinary human being, that ये टेक्नोलॉजी का जमाना है, ये टेक्नोलॉजी का जमाना है, आगे आगे बहुत कुछ दिखाना है, ये टेक्नोलॉजी का जमाना है, आगे आगे बहुत कुछ दिखाना है, पत्थरों पे गुलाब खिलाना है और आंधियों में चिराग जलाना है। आज अगर किसी को कहें कि पत्थरों पे गुलाब खिलाना है, आंधियों में चिराग जलाना है, something difficult, but probably AI, machine learning, and all these advanced technologies which are on the card will certainly make that to happen. Thank you so much. Keep learning despite disruptions all around us. Stay safe, stay healthy, stay vibrant. Take care of all precautions. Though we are reopening back, the country is back to its normal functioning, and let's make it more sustainable, more momentous by following all type of preventive cares. Thank you so much. Wish you all the best. Over to you, Ayushi.
Thank you, sir. Thank you for always being the motivating force. I would now welcome amongst us our guest speaker, our expert speaker, Professor Swagatam Das, sir, Head of the Electronics and Communication Sciences Unit of the Indian Statistical Institute, Kolkata. Professor Swagatam Das, sir, has done extensive research on evolutionary computing and machine learning. Dr. Das has published more than 300 research articles in peer-reviewed journals and international conferences. He is the founding co-editor-in-chief of SWARM and Evolutionary Computation, an international journal from Elsevier. He has also served as the associate editors of the IEEE Transactions on Cybernetics, IEEE Transactions on Evolutionary Computation, Pattern Recognition, Neurocomputing, Information Sciences, IEEE Trans on Systems, Man and Cybernetic Systems, and so on. He is an editorial board member of Information Fusion, Progress in Artificial Intelligence, Applied Soft Computing, in Engineering Applications of Artificial Intelligence, and Artificial Intelligence Review. Dr. Das has 25,000 plus Google Scholar citations and an H index of 75 till date. He has been associated with the international program committees and organizing committees of several reputed international conferences, including NEUR IPS, AAAI, AISTATS, ACM, Multimedia, BMVC, IEEE, CEC, GECCO, SEMCCO, etc. He has acted as guest editors for special issues in journals like IEEE Transactions on Evolutionary Computation and IEEE Transactions on SMC Part C. Not only this, great visionary Das sir is the recipient of 2012 Young Engineer Award from the Indian National Academy of Engineering. Thomson Reuters Research Excellence India Citation Award as the highest cited researcher from India in engineering and computer science category. He has also been rewarded the Best Associate Editor Award for IEEE Transactions on Cybernetics from the IEEE Systems, Man and Cybernetics Society or in 2020-21. We are honored to have you amongst us, sir. I welcome you to this session. I would now request you to please enlighten the house. Please, sir.
Thank you very much for the kind introduction, Dr. Chopra. I'm indebted to my very good friend, Professor B.K. Panigrahi, Professor Huda, Professor Subroto Mukhopadhyay, and other senior colleagues from IEEE Delhi section. I will now share my slides and we will very soon start the talk. So I hope the first slide is visible in full screen.
Yes, sir.
Okay.
Yes, sir, it is visible.
Fantastic. So if you look into the first slide, in fact, people who works in machine learning should be very good at identifying the right piece of data. In the first slide, the most important piece of data is my email ID, which is written here. If you have any offline question or require any kind of reference about any topic, you could simply drop me an email and I will try to revert back. Okay. Now, as other dignitaries have already mentioned, the term machine learning is no longer confined as a research jargon, but it has entered into our daily lives in various ways, into our tea parties, career planning sessions, everywhere. People talk about big data, machine learning, artificial intelligence, all these things. So in this talk, I will first try to provide a high-end introduction to the concepts which are fundamental driving forces in machine learning, and then we will look into the rate of success of machine learning given the irregular behavior of data that come from real life. You know, you might have heard that this cliche quote that data is the new oil. If data is the new oil, then the machine learning algorithms, the deep networks and so on, they are the new engine which feeds on that oil. If the data is not reliable, if the data is violating certain statistical assumptions, if the data is biased, in those situations, just like if you pour oil into your car's engine, the car will start malfunctioning. It will not drive you to your destination. In a similar manner, the machine learning algorithms also start failing, however intelligent they may. So that part and some auxiliary mechanisms to handle such data irregularities will be the main theme of this lecture. So we start with a very light note how traditional machine learning algorithms differ from traditional softwares. Okay. So in traditional programming, that is called basically a deductive, they are based on deductive logic. There is a smart person who identifies a set of rules and codes them up. And then it's just like a clerical manner, those rules are executed and calculations are made. On the other hand, the machine learning solutions are built around the inductive logic. There is no learning involved during the calculation of our pay slips. We just say, okay, this much of dearness allowance is to be added, this much of income tax is to be deducted, and so on. So there is no learning. You see, basically, in traditional programming, we provide the machine with some data and some program, which is basically a sequential set of instructions, each step of which must be followed on the data, and an output will be produced. Like the data could be unsorted lists of integers, and the program could be a typical sorting algorithm, maybe bubble sort or merge sort or something like that. On the other hand, in machine learning, we provide a small portion of the available data, and we also provide what we want from that data. As example, we provide some desired output, which is already computed or provided by a human expert. Then there is a training process through which the machine is expected to create a program, a machine learning system, or a model. All these are synonymous. This model, when new data comes, which is previously unseen, when new data items come before the model, it will carry out certain calculations and produce an output which is similar to the user-specified output at the input side of this system from the new data. It's like I am providing some unsorted lists of integers. I am also providing some corresponding sorted lists of integers. I can specify certain constraints, like you need to sort these lists occupying minimal amount of memory space, doing minimal amount of arithmetic computations, etc. And I expect the algorithm, the machine learning system, to write down the sorting program by its own self. You know, automatic program generation or program synthesis has now become a very interesting part of the modern machine learning systems. So they can write programs and they can adapt the program for different instances. This is what our expectation is. Okay. Now, we are all familiar with science fiction movies, and it could be tempting to think that machine learning is some magical device, some magical developments. Machines can attain human level intelligence. Even if this could be true in far future, we are still light years away from realization of that. Till date, what we see machine learning as like an assistive technology which can greatly reduce the human efforts, okay? Given that proper, well-behaved data is supplied to these machine learning systems. So we should not view machine learning as a silver bullet which could solve any problem. It's much better to think of machine learning like this straw, which this modern crow will use to suck up the water from this jar instead of putting stones one after another and waiting for a long time before the water comes to the mouth of this jar. Okay, you remember the Aesop's fable, might be. So this is how we should see machine learning, in fact. Now, coming to my talk will be concentrating on supervised learning framework. In supervised learning framework, the entire business could be summarized through this very simple mathematical notation, y is equal to f of x, where x is basically an abstract representation of the data. What is data? Anything and everything around us which could be abstractly represented and processed by a computer in the form of certain numbers sitting together, which ultimately gets converted into bits and bytes, that qualify as data. When I go to a bank and ask for a loan, a file opens in my name and I become a piece of data. We all. Okay. So this X which enters into this function, the function is like a factory, like the raw material who goes in X. What is X? It's an abstract representation of a data, piece of data. F of X is the machine learning model, or we can call it prediction function, or we can call it a classifier based on our application. Many names are there. What is the finished product from this function? What is the outcome from this function? It is Y. What is Y? Y could be one of the pre-specified categories into which X should belong. So to create this model, we show the machine a small portion of the data world for which already the Ys or the categories are computed by some expert. Like I can show the machine maybe 100 chest X-ray images, and these chest X-ray images have been labeled by some very expert doctor, lung specialist, who will see the fibrosis pattern. You know, fibrosis is a white cloudish pattern which forms if pneumonia grows in a patient. And the doctor, looking at the fibrosis pattern, classifies these images into 3 pre-specified categories. Maybe COVID-induced pneumonia, bacterial pneumonia, and benign. So 100 such images have been labeled by the doctor because doctor's time is extremely costly. Doctor has labeled only 100 or 200 images. These images are shown, provided to the machine as training images, and then the machine builds up this system. Our machine learning model is created by using lots of statistics and mathematics. Finally, before deploying the machine, we also provide some chest X-ray images for which we know what are their right classes, but we haven't shown those classes to the machine. And we see if the machine's predicted class matches with the doctor's prediction. This part of the data is called the test data. If the machine succeeds in the test, then we can deploy it in the outpatient department of a crowded hospital where people coming with lung congestion and other symptoms can get quickly diagnosed. Initial clinical diagnosis could be provided by this machine. So see, in supervised machine learning framework, supervision or teaching is actually the process in which the human expertise, like the expertise of the doctor, translates into the machine in the form of training data. Okay, so this is the whole business. You have some training data, you express each of them in terms of certain numbers sitting together, which are called features. Then you assign certain labels from the experts for your training data. Based on this training data, an algorithm is created. Now, some unseen data has come. the feature vector extracted from the unseen data goes through the same algorithm. It provides an output for or a predicted class for this unseen data, and we see how good it is doing before actually deploying it. That's it. Now, this simple structure now has been extended to very broad contexts. Machine learning, still you can view it as construction of a function f, which maps an input x into some output y. We have two very classical examples of machine learning. One is regression. Output is a real scalar in that case. And the other one is classification. So in regression, how the output real number y depends on x. Is there a functional dependence based on which we can predict the value of y given some x? Like, let's say, how many credit cards are used per household in a posh area of Delhi? That is y. And that y may depend on the family size and the family income. These are the two components of the vector x in that case. And we want to see how this number of credit cards bears a functional relationship with these two parameters. That is regression. In case of classification, the output is a discrete output. It could belong to one of the three pre-specified classes, which could be encoded like this, or one of the two pre-specified classes, benign or malignant, an online transaction, genuine or fraudulent, a signal coming from a process plant, faulty, that means there is some anomaly inside the plant, or normal. This way we can make 2 or 3 or 4 pre-specified discrete categories. On the other hand, now it extends to structured learning or prediction, where the output could be a sequence, a matrix, a graph, or even a tree. Gone are the days when we would have been very happy to look into iris flower dataset that had only 4 pre-specified features. Now every Facebook profile is a data item. Okay, that profile may contain many images, text, documents, video clippings, and many such things. And then mining those profiles, you could get some idea about the opinion of the Facebook users from a particular region about some particular issue going on. Okay, even the political opinions could be mined in that way. So you see, the nature of the data has been drastically changed. As a result, we are more into structured learning, where the output is composed of components with dependence, like machine translation. Here, input X is a sentence in language, some language like Chinese, and the output is basically some translation into English or some other language. Speech recognition input could be a speech signal, output could be the corresponding transcription from the speech. Chatbot, we all know, you type a sentence you want to lodge a complaint, so you type a sentence and the output is simply the response from the machine. Similarly, we could have matrix also in image-to-image translation systems. So you provide this particular image, and then the machine gives you, against the hand-drawn image, the machine shows you a real image of a building. This image is actually synthesized. It looks like a camera-clicked image, but it is actually an artificial one, right? And you see, so similarly, colorization and even cross-domain translation. So you provide a line of text, okay? X is a line of text, and Y, what the machine gives you against these lines, it gives a befitting flower that matches the description in this text. That's called text-to-image translation. So many such things are happening. So, for example, this is just a simple classification system, how the self-driving cars navigates through segmentation and classification. It segments every person inside the image, and every part, pedestrian, cars, street lights, and it also says what it is with certain percentage of chance. Or it can create a heat map of the universe lying ahead of it, and based on that, the car has to navigate. This is just an example of a machine learning system in regular use. Okay, but now there comes the critical situation. As I said, all the machine learning algorithms, be it the classical decision trees, key nearest neighbors, or the latest deep neural networks like ResNet 50, GoogleNet, Inception, V3, all algorithms assume certain idealistic, conceptions, restrictions on the data. Like the first very interesting assumption is In the training set, all the classes must be equally represented. So if there are two classes, maybe we are examining the lung CT images, whether some nodules have formed or not. Nodules are an indication of lung cancer. So we need, for an algorithm to do a very good classification, we would need 50 images. If we are providing total 100 as training set, we would need 50 images from benign class, 50 from malignant class. Similarly, all the subconcepts within a given class must be equally represented. What is meant by subconcepts within a given class? If suppose you are going to make your machine distinguish between apples and oranges, now within the apple class, there may be green apple, yellowish red apple, reddish orange apple, so many varieties. So if you show inside your training data only green apples to your machine, obviously when certain red apples will come or yellowish, orangish apples will come, the machine will classify them as orange. So you need to provide the internal variations within the class. These are called subconcepts, okay? All the classes must have similar class conditional distributions. That is a statistical requirement actually for the success of machine learning algorithms. We have to assume that all the classes are sampled, all the data are sampled from underlying probability distributions which have similar shape and size. Okay? That's why, you know, statisticians very often assume everything comes from different Gaussian distributions because they are very much comprehensive. Beautiful mathematics can be done with them. But as I have written here, life is hardly so easy. So real life data very often doesn't follow Gaussian distribution. Another number 4 and 5, if you see, all the values of all the features must be defined for all the members of the data set, first of all. It should not happen that for some members, some features do not exist. Okay. So if you go to for example, I go to a bank, I told you I become a piece of data when I apply for loan. Now, if a student goes to the bank, okay, and applies for a loan, the student may not fill the column of annual salary because that doesn't exist for the student. Okay. So the annual salary feature may not be defined for that student. Similarly, the fifth requirement is all the features must be known for all the data instances. If some features are not known, if some features are not recorded because of equipment failure or sensing device failure, then those features have to be somehow filled in. If you leave them blank, certain algorithms may not completely work. So given such idealistic assumptions, real life data always violates them. Based on such violations, we provide a taxonomy of the data irregularities. These are the bad behaviors of data, apart from other bad behaviors like biased sampling, lack of security, and also the data hiding tendencies. Okay, we are not going into that. We do not usually have control on those parts. But if we look at, from the algorithmic side, if we look at the data irregularities, there are two types of them, distribution-based and feature-based. In this distribution-based irregularities, class imbalance means one or more classes are greatly outnumbered by other classes in the training set. One class may have 2 samples, the other class may have 200 samples. Okay. Class Q means the conditional distribution, probability distributions are not symmetrical or identical. Small disjunct means the internal variations of the class are not equally represented. And you can see among the feature-based irregularities, we have either the features could be missing, the equipment or the sensing devices failed to record their values, or the features may not at all be defined for certain data items. These are the gross data irregularities which we can manage algorithmically. On the other hand, I will show some examples. If the data is corrupted in other ways, if there are inherent security lapses in the personal healthcare data coming in smart city analytics, or if the data is biased, certain survey forms are not filled or filled with imaginary responses, we cannot help. All algorithms will start failing. Okay, and data hiding has become almost a trend to baffle the machine learning systems at various levels of our society. I'm not going there. So here, what I mean to say is, so given these irregularities, the machine learning algorithms will look like these cats. They will become confused, they won't understand what to do, and all of them start failing. Okay? So if you look at the classical machine learning algorithms like neural networks, these are sensitive to class imbalance, small disjuncts, absent and missing features, k nearest neighbors. They are immune to the class distribution skew because they make no assumption about the probability distributions. Decision trees, for example, they are inherently immune to feature missingness because they work with a small subset of features. But of these 5 types of data irregularities, all the algorithms are affected by one or more of them. Okay, that's where some auxiliary mechanisms must be there to counteract these things. Class imbalance is a terrible problem, and it is the most commonly occurring form of data irregularity. As I said, one class is having very few samples in the training set and the other class is having a lot of samples. For example, I provide 100 lung CT images to detect the lung nodules. Of these 100 patients, maybe hardly 3 patients will show such nodules, fortunately. And these are the earlier symptoms of lung cancers. They may be chain smokers and they're developing such cancerous nodules. Your machine learning algorithm completely misclassifies these 3 persons, stamps all to be benign. So the error it is making is only 3 out of 100. So its accuracy is 97%. You should be very happy. My algorithm gives an accuracy of 97%, but it is of no use because it has missed the target class. Okay. Similarly, in the real world situations like credit card fraud detection, detection of oil spills from satellite images, credit card fraud detection, online transactions are recorded in the central server of National Payment Corporation of India or NPCI for certain, merchant websites. And in 1 week, if it's a normal course of not lockdown, normal situation, in 1 week, there are almost 3 crores of transactions all over India. Out of the 3 crores of transactions, only 5,000 hardly will be fraudulent. The rest are genuine. And then NPCI would look for some machine learning based algorithms to detect such fraudulent transactions. Okay, and then they will take the measure. So you see, in the training set, if we collect 1 week's data and map them into fraudulent or genuine manually, we have almost 3 crore in one class, and compared to that, only 5,000 to the other class. So it's very, very difficult. Usually it's like you practice sums for an exam tomorrow, you practice 100 sums from the chapter of limits and continuity, and you practice only 3 sums from the chapter of permutation and combination. So in the exam hall, next morning, you are very confident on limit and continuity. Any unseen sum, you will do it in just at one go. But any unseen sum from permutation combination, you are very disconfident. You cannot tackle them with proper manner. You will pant and puff and you will turn yellow because your learning in that chapter is incomplete due to lack of enough examples. The same thing happens for the machine learning algorithms also. They face a huge trying time in tackling such, unbalanced class imbalance data. It's much like this. And even if the minority class, which has very few samples, is small, it could be much more important than the majority class. The major effort should be in detecting the minority class itself. Then if we add biased training data, okay, with class imbalance, it's like adding insult to injury. You might have heard this. So this portion is the probabilistic data space for this blue class, And you see blue class is the majority class here. Multiple samples have been provided in the training set, which covers almost the entire geometric data space. However, for this red class, unfortunately, very few points are there. And then again, these few points have been sampled from a small portion of the data space. They have not been sampled uniformly over the data space. This is called biased sampling. The training data, like you are going for post poll, opinion poll, okay? What we call exit poll opinions. And then you are asking only in a particular area, you are only asking the rich and famous people, the professors. Who do you want to see as the next prime minister or chief minister or something like that? You are not asking the common people. You are not going to the grassroots level. You are only going to good, well-decorated houses and asking them. So what you get is a biased opinion. Okay, based on that, if you predict something, that may utterly fail. Similar thing happens here. You have biased data. So the ideal decision boundary is like this one, which minimizes the Bayesian risk. But if you employ a classifier like support vector machine, it will end up with this solid green decision boundary. And then when during the testing phase, new data items emerge from this uncovered space of the minority class, all of these will be misclassified. That is the problem of bias training data. And the machine learners don't usually have control on such training data. Okay. So also the relative imbalance versus absolute rarity is a big issue. If the minority class has only very few data points, like only 1 or 2, then we cannot infer anything about the data space from where they are coming. On the other hand, if the majority class is highly outnumbered, by the minority class also contains, let's say, 1,000 or 1,500 points, which are uniformly distributed over the data space, then we can at least infer something about that region of data and say something. Okay. So a great deal of it depends on the performance measures as well. Suppose there are 10 samples from one class and 100 samples from the other class, you can create a confusion matrix like this. And let's say your machine learning algorithm has predicted 2 from the minority class appropriately and 8 have been misclassified. On the other hand, it has inferred the right label for all the 100 samples from the majority class. In that case, this will be the form of your confusion matrix, and you can calculate various classical performance measures. You will see the accuracy comes as 0.98 because only 8 samples have been misclassified. Similarly, you will see precision is 100%, F1 score is not bad, and so on. Given this, classical performance indices, one very interesting performance index for capturing class imbalance is the G-mean index, which have been discussed and analyzed in this paper. So suppose 96 negative class samples and 4 positive class samples. 4 may be in a disease class, rare event. Unfortunately, in machine learning and statistics, positive means the person has some disease. COVID positive is a very negative news, but we call it positive. Okay, so we have 96 negative class samples and 4 positive class samples. And the classifier predicts all samples in the negative class. So our accuracy is going to be, this is the confusion matrix, okay? Predicted negative and actual negative, 96. Predicted positive, none. All the 4 have been, which are actually positive, have been predicted as negative, okay? So that gives the accuracy to be 0.96, but the true positive index is 0. Therefore, TPR is 0 and G-means is 0. Had these 4 been rightly classified, we would have the G-mean index equal to 1. Therefore, G-mean is a very nice index for detecting the class imbalance. Usually, there are 4 basic approaches. I said some algorithmic approaches are there to handle class imbalance. There are 4 basic approaches. One is called oversampling, where you artificially generate synthetic samples in the minority class so that the size of the minority class may be almost equal to that of the majority class, and the classifier may not get biased. One such very interesting algorithm is the synthetic minority oversampling technique, or SMOT. Similarly, The other way around is the undersampling. These two, oversampling and undersampling, are basically the data rebalancing technique. In undersampling, we can remove certain points from the minority class, from the majority class, so that the majority class is downsized. Apart from this, we have the cost-sensitive methods, which could be computationally very intensive. In cost-sensitive methods, what we do is we heavily penalize a misclassification from the minority class. Minority class misclassification will be highly penalized. Majority class misclassification, still okay, not that much penalized. Okay, we optimize the objective function with giving unequal importance to minority and majority classes. Then we can combine these approaches and get into algorithm level approach like kernel modification, active learning, rank matrix, and multitask learning, and so on. Okay, so these are the concepts of data rebalancing. I will very quickly go through these and come to the main portion because the time is very limited. So the data rebalancing, in undersampling, we remove parts of the minority class. In oversampling, we create in undersampling, we remove parts of the majority class. And in oversampling, we artificially create samples inside the minority class so that they look balanced and the classifier may not get confused. Oversampling, as I said, the best way is to show you just an example what we do. This is an imbalanced data set. You have multiple points in the minority, in the red star class, which is majority. And in the minority class, we select, so what MOTE does, MOTE is a classical approach computed, I think, proposed in 2002. And you see what we are doing. We select any one of the minority samples like this. Then we select some of its nearest neighbors, here 3. Then we randomly select one of these nearest neighbors, connect it with the actual point we selected, and we generate a new point here on the line joining these 2 points by a convex combination of the target point xi and its nearest neighbor, which is xj. So this way we create new artificial samples in the minority class. And the amount of oversampling, how many new points you need to generate, depends on, based on that we can select the nearest neighbors, and it is very easy to compute. So this is actually the situation after running a program. You can see the newly generated artificial red process are linearly arranged because we are joining 2 points, and then on the line we are actually placing the newly generated points. So another approach, I'm skipping some of this because of the lack of time. Another approach could be SMOTE added with TOMEC links. What is that? You have this class imbalance. Then you artificially populate the minority class and generate many minority points. Minority points are these orange boxes. Then you identify those pairs in which 1 point is from the majority class and 1 point is from the minority class. These are called TOMEC links. So you identify such TOMEC links and simply delete all of them from your training data. As a result, the separation of points of the 2 classes increases. And if the 2 classes are well separated, it's very easy job for the classifier to demarcate them. Okay, so this is another illustration. You have, this is the initial data distribution, then you do SMOTE, then you identify the TOMEC links, and then you simply remove the TOMEC links and get well separated data like this. In random undersampling, we have to delete certain points from the majority class, as you have seen here, but that runs the risk of deleting points from the overlapped portion of the 2 classes. These overlapped regions are very important because the classifier mostly fails if there is a huge degree of overlap between the 2 classes. That's why sometimes we do undersampling with edited nearest neighbor. That's an approach which was very popular. So what we do is we see how many nearest neighbors of each majority class point belong to the minority class. If the majority point is surrounded by minority points, then we delete those points and we expose that data space, we reserve that data space, better I say, for the minority class. Okay, this is what happens after undersampling and oversampling. We could do data augmentation as well. So in data augmentation, what we do is we take the minority class samples and also the majority class samples, and we perturb them to create more points into the minority class. This is Nowadays, it is called data augmentation, but it's just another form of oversampling, basically. Cost-sensitive learning, as I said, we will give different weightage to misclassification from the minority class and misclassification from the majority class. Okay, this is, I'm not going into the mathematical details that are there inside this paper, which is very well cited by now. So here we modified a classical SVM. The classical SVM objective, which minimizes this margin width, basically, has been added with two penalty terms. One for this row plus penalties for the majority class and row minus penalties for the minority class. This was called near Bayesian SVM because it showed that the margin of classification could approach the Bayesian decision boundary if we properly optimize this modified SVM objective. Let me illustrate the class imbalance issue with another very interesting algorithm and very well-known algorithm called k-nearest neighbor. You know, k-nearest neighbor carries the training set with it. As soon as a new query point appears, it measures the similarity of the query point with all members of the training set, and it then picks up the nearest neighbors. Among the nearest neighbors, it looks into how many, to which class most of the nearest neighbors belong, and then it infers the same class for this query point. So it operates by a simple philosophy. A person is identified by the company that he or she keeps. If all your friends are good and sober, then you are also very good, sober gentleman. Otherwise, there is a problem. So now this nearest neighbor classifier is one of the easiest classifiers to implement and to interpret, to understand. That's why it is very famous among the practitioners. Okay. Now we can very simply modify it for handling class imbalance. That approach was shown in this IEEE Transactions on Neural Networks paper. What we are doing is, if there are C classes, and it's a multi-class imbalance handling method. I was talking about two classes until now, but you could have multiple minority classes and multiple majority classes. So what we are doing is, if you have C classes, the ideal probability of occurrence of each class is 1 upon C. If you have, for example, two classes, ideal probability of occurrence of each class is half and half. Okay. But the actual probability of occurrence of each class could be computed by looking into how many members of that class is present in the whole training set. If 30 members are from class A out of 100, then the probability of appearance of is my PPT still visible? Somebody has written the PPT is not visible.
It's visible, sir. It's visible.
Okay. Okay. So if you have 30 samples from one class and 70 from the other class, and if you randomly select one data point from the training set, then what is the probability that it comes from class A, which has 30 samples? Very simple, 30 by 100. From the other class, 70 by 100. So the original probability is NC by N. If both classes have same number of representatives, 50-50, then the original probability will be equal to the ideal probability. 50 by 100 is half, you know that. So the class specific weights are computed by dividing R with PC. If PC is very different from R, then the class specific weights will give us a nice edge into revising the number of neighbors in different classes. So this picture will make it very clear. This is basically the algorithm that we proposed. This is the k nearest neighbor. This is a class imbalance data. 16 points from the red class, 4 points from the blue class. Ideal probability, since two classes are there, ideal probability of appearance of each class is half and half, 0.5 and 0.5. And the actual probabilities for the blue class 4 by 20.2 and for the red class 16 by 20, which is 0.8. So the weights of the neighbor counts from the two classes are what? It's R by PC. So 0.5 by 0.2, which is for the blue class, our weight is 2.5. For the red class, our weight is 0.5 by 0.8, which is 0.625. What does this weight means? This weight means if we see, if a new query point arrives and we see all the three nearest neighbors are from red class, so the counts in the two classes from blue class 0, from red class 3. Now in this modified algorithm, we are going to multiply these counts with the weights for each class. 0 into 2.5 is still 0, 3 into 0.625 is 1.875. So if you look at the weighted count, still this point will definitely belong to the red class. But if you look at this point, which appears here, there is a high chance that this point is actually a blue point, although two of its nearest neighbors are from the red class. So a classical KNN will stamp this point into the red class. But what we have done here is we are revising the neighborhood count. So 1 is multiplied by 2.5 and 2 is multiplied by 0.625. As a result, you are getting the revised neighbor count as 2.5 from blue class and 1.25 from red class. What is our classification rule? We will infer that class to which majority of the nearest neighbors belong. So if you look at the revised count, majority of the nearest neighbors are belonging to which class? Blue class. That's why in this case, this revised KNN will put this point, this query point, to the blue class. Here it is definitely in the blue class. So this algorithm, which was called as a global imbalance handling scheme, was compared with multiple other forms of neural networks and KNNs on different data sets, and we evaluated the G-means and we got very good results. Deep learning is there in the class imbalance plagues the deep neural networks also. In deep learning era, there are huge applications of class imbalance. You can see this is one class imbalance data set which was proposed in the famous NeoRIPS 2017 conference. This has 397 classes. You see, it's a multi-class data set. It has been very well analyzed in this very recent survey of ours. And in this in this data set, the class distribution is showing you a long tail. Long tail means some images, some 397 is a collection of images. Some images appear very high number of times, while some images like the public library kind of class, these images appear very less number of times. That is the situation with multi-class class imbalance. And it is not very well studied, but currently gaining huge attention, because in medical imaging, image-based diagnostics, in climate informatics, you need to show when there will be a sun radiation flare. You need to see from the aerial images how the the ocean currents are changing, how the polar caps are melting. You may want to predict the locus of a tornado. So in this climate informatics is hugely dependent on processing of high resolution images taken from multiple sources. And most often such processing requires handling of class imbalance, because calamities in the climate are still rare events. Okay, that's why human civilization still survives. That's why class imbalance is generally getting attention. I'm not going to talk about all these details, but usually what we do is we can include a smooth type mechanism after the image features are extracted by the convolutional layers of a deep neural network. Deep nets can automatically extract the abstract and high level features from an image and they can embed the high resolution image into a very small dimensional vector, each component of which summarizes one abstract and higher level feature of the image. So in that embedded space, we can add multiple synthetic samples. It depends on how you are generating those samples. If you generate them in a naive way, like these people did, it's called deep oversampling. So if you generate them in this way, they may not work. So what we did is in ICCV 2019 conference, this is one of the biggest events in computer vision, we came up with the GAMO. GAMO stands for Generative Adversarial Minority Oversampling. I don't know how many of you are familiar with GAN. GANs are the generative deep inference models which try to estimate the underlying probability distribution of the classes from which the data points are sampled. Okay, generative adversarial networks, which was actually a 2014 breakthrough, and then it is said to be the most interesting idea in last 10 years in machine learning. What GANs can do is very interesting. They can generate very realistic artificial images of some specific kind. If you show GAN images of different, let's say, Bollywood actors, okay, Shah Rukh Khan, Salman Khan, and many more, Vinod Khanna, Amitabh Bachchan, and so on, then GAN can generate the image of such a person who will look like a Bollywood actor, and the image will perfectly look like a camera clicked image, but the person was never born on earth. Okay, it's a synthesized artificial image, and GAN can do that under many certain conditions. Okay, so what in GAMO, what we did is there is some explanation regarding GAN which I want to exclude. So in the GAMO, the main idea was to use GAN for generation of artificial images in the minority class. When we are using no additional mechanism and your classes are non-convex, the minority class is this red one, the unaided classifier looks like this one. So you see many red points are misclassified. It's like a person has cancer and the medical system says, oh, no, you go home, smoke many more cigarettes, etc., which is life costing, very dangerous. Then on the other hand, if we add a normal GAN network with convex generator and classifier, it can take all the minority classes on the minority samples on one side by generating these green artificial samples, but at the same time, it misclassifies many majority class points, which are also very dangerous. Majority misclassification means a person doesn't have cancer, but the machine learning system says, oh, you have cancer. So you start taking chemotherapy, and that will be disastrous for the, for the health condition of that particular person. So there comes GAMO. So GAMO, what it does, it's a 3-player architecture. Normal GANs are 2-player. You have a generator and a discriminator. Inside GAMO, we have a convex generator, we have a classifier, and we have a discriminator. The discriminator actually uniformly spreads the newly generated points inside the minority class, and the classifier, therefore, is unbiased. The classifier, lays its boundary wall like this one, rightly classifying most of the minority and majority points. And we saw that through results, etc. All these results and codes are freely available through our paper. I will share these slides with you. It is free from mode collapse and other things. So I will very quickly go through the future aspects. Small disjunct is a very big issue. In case of class imbalance, if the internal variations of a class are not properly covered, internal variations can appear as small clusters within this minority class. If they are not properly covered, then lot of problems will be there. Until now, so this is it. I was talking about this example. You have the apple class. Within the apple class, you have green, red, yellow, yellowish red, so many varieties. So strangely, in machine learning research, very few works have been done on handling such, class small disjuncts or internal variations within a class. So these have been defined here, and very few works are done inside the decision tree literature. Deep neural networks have not yet been properly researched to handle the internal class variations in the minority class. Class distribution skew is like this. One class has a spherical distribution, the other class can have a elliptical distribution, and in that case, most of the classifiers will give you a very poor decision boundary, which will be completely disagreeing with the ideal or Bayesian decision boundary, which has been shown with the, with this black line. Okay. Feature-based irregularities, there are very good, surveys over here. As I was saying, types of feature missingness could be classified into 3-4 types, like missing completely at random, missing at random, and so on. So missing at random, or MAR, this missingness depends only on the observed feature values. Like college goers are less likely to report their income than office goers. But you never know whether a college goer will report his or her income. And that is independent of the actual income. A college goer may do huge amount of private tuitions and earn a lot. But that boy or girl may not want to report the actual amount he or she earns. So you have multiple such missingness. Absent data is called also forced structured missingness. Like you try to write a tree, all the pixels on that tree are not there because at some point of time your pen malfunctions and the ink is not coming out. There is a very nice paper in Journal of Machine Learning Research which first tells us about this absent features problem. Various approaches are there to handle such, absent feature problem. One such approach was devised by us, which was called Penalized Dissimilarity Measure, or PDM, which actually, comes up with a new type of distance function to deal with the absent or missing features. Okay, and we used it for classification as well as for clustering, and these two quite well-cited papers were published based on this penalized type of dissimilarity measure, which can deal with feature missingness. Okay, then these irregularities can also come with combined form. Class imbalance and missing features can come together. Class imbalance and absent features, class specific missingness, disjunct specific missingness. Certain features are not defined for certain internal variations of a class. Okay, that can also happen. Co-occurrence of these feature distribution based irregularities, these are some examples, like credit card fraud detection comes with class imbalance and class Q both. Intrusion detection, anomaly detection is a great example of class imbalance. Breast cancer diagnosis from digital mammograms come with class imbalance, class Q, and small disjuncts. In business analytics, market segmentation is a very big challenge, and the profiling and market segmentation is a great example of two data irregularities that are called class imbalance and class Q. So they can come in pairs, and we have miles to go before we sleep. Theoretical analysis and insight into machine learning algorithms and the effect of data irregularities on such algorithms have not been there in much. We are still in infancy, given the theories. We lack standardized and uniform benchmarking because most of the real world data should come from industry level, industry actually, like Facebook, Google. They have huge amount of data. Amazon, they have trillions of data, and those data, they usually do not diverge. That's why the public data on which the current academic research on machine learning goes on are kind of toy data in which most of the irregularities are tackled. But when it goes to the industry, I talked about the NPCI, huge amount of class imbalance. Okay, such things are not available for the academic researchers to work on. So we need to build up proper benchmarking suits in collaboration with the industry. Okay, and of course, industry means especially these type of industries like Amazon, Netflix, Google, who handle trillions of browsing people. So the browsing history, there is a famous saying that your internet browser knows you much better than even your husband or wife. And that's true. So your browsing pattern reveals so many characteristics about you, and all those data are actually stored. Similarly, we are lacking standardized and appropriate performance metrics for this sort of data irregularities, semi-supervised learning from class imbalance data. These are some areas which require urgent attention from the machine learning people if they want to deploy their algorithms in really exciting applications like cars. As I said, after next 5 years, the upcoming area is going to be climate informatics, because the climate of the whole world is changing at a rapid pace. Most of the countries pay least attention to this fact. You see, a war is happening at this point of time after we have suffered 2 years of COVID. It's going to be, God forbid, it may turn into a nuclear war. And what effect will it have on the climate? The polar caps, the ocean current, more tornadoes, all the seasons shift. Machine learning tools and techniques at least can give very accurate prediction of multiple such calamities, provided these data irregularities are appropriately taken care of. So anyway, with this, I have almost exceeded the time. With this, I would like to conclude multiple things I have touched upon within this short time. If you require explanation or more reference to any of these, kindly contact me. I can see many questions, so maybe I can take some of them now. So can I take the questions now?
Thank you, sir. Thank you so much for the enlightening deliberations, sir. I'm sure this insightful session would have enlightened the participants about the real life applications and about the intricacies of machine learning. There are some questions by the participants I would like to take up with your permission. May I, sir?
Sure, please.
So the first question is there any forum we have for real life experience of getting to work into the areas of any organization where we practically use machine learning?
See, many organizations, even inside India, regularly use machine learning. Starting from Ola and Uber, these taxi cab apps, they use huge machine learning experiences for geographical information systems. Then going to the online payment corporations like NPCI, going to the digital marketing companies, even coming to hardcore processing industries like the smart factories. They also employ a lot of machine learning for fault diagnosis, for prescriptive repairing of their supply chain lines and logistic chains. Multiple companies are there. If you want to do a good internship, you need to find one such company. Unfortunately, very few forums are there where you can actually access the industry level data as a common man. Because industries always have their non-disclosure agreement for their data. I can tell you one such, you can search on Google for this CARLA, C-A-R-L-A. CARLA stands for the Tesla 4.0 self-driving cars, and the self-driving cars, they accumulate huge amount of data of these road sceneries, road pictures, different signs on road. A self-driving car needs to detect whether it's a stop sign or a go sign. So these data, they have made a part of this data public through the CARLA website. If you use that data, you can have such an industrial, maybe a proxy for the industrial experience. Okay.
Thank
So
you,
can
sir.
I go
Thank
to the
you.
next question?
Yeah, the next question is how could a data be biased and what are the probabilities and outcomes? How could a data be biased, the probabilities and outcomes, sir?
Yeah. So I already told you that if your data comes from different users, in fact, data, what we call as data, it's basically, it tries to characterize from the business analytics perspective, the data always tries to characterize human beings. And from human beings, the data comes through various channels. One very unbiased channel which really characterizes a human being is your browsing history, basically. So the browsing data is collected by all merchant websites, including Netflix, Amazon, all of them. You see, even now, our smartphones and all these devices, the voice assistants, if I tell my wife that my t-shirts have got torn here and there and I need to buy new t-shirt a few times, and I have an Alexa in my home. So next month, Yahoo sidebar, I see a t-shirt and other t-shirts. So how do they know that I am seeking t-shirts and I may buy one from them? Because the data has been diverged from Amazon to Yahoo and to other merchants. Okay. But when it comes to survey, when there are different government channels or other company channels, survey data is very easily manipulated. And it is manipulated actually at different levels of our society. Everybody does that. So when the survey data is manipulated, you may want to show that, in fact, every year, the government wants to, showcase some success. Actual survey data may not agree to that. So naturally, there will be pressure on manipulating the survey data. And if that happens, then we have this biased data. The survey may have happened. You have collected 10,000 people's reply, but those 10,000 people have come from a certain social strata. So that doesn't actually reflect the complete scenario of our society. That is the biased data. I was showing now a few points from a small portion of the data space. This is exactly the case. And if that happens, then machine learning algorithms must not be blamed because they will provide the output as per their input. That is the biased data. Okay? And nobody actually has a control of the biased data. That is why nowadays, sampling survey, ethics, fairness, especially the ethics and artificial intelligence, this type of subjects are being taught so that people can resist such bias at various levels. Okay.
Okay.
So we can go to the
The
next
next question
maybe.
is, sir, machine learning has affected almost all spheres of life today. But what are the challenges due to data analysis that going wrong in any situation? So is it possible, and what are the after effects? What would be the after effects?
The after effects could be devastating if the data analysis goes wrong. That is why before deploying a machine learning algorithm in a serious situation, I told you about the test data and training data. That is why we need to have a huge amount of validation and test data for which we know the answer, the machine doesn't know the answer, and we just put our machine to an examination. Such kind of, these are called validation experiments and quality test. So such quality test and validation experiments must be undertaken as much as possible before you deploy your machine for giving a tornado signal or for a medical diagnostics, where one wrong decision from the machine can be life-threatening. Okay, so of course there are situations when the machine learning system can fail, but if it goes through as much as possible unbiased validation scenarios, careful test scenarios, then it may not fail most of the time. That's a hope. So you see, human beings are prone to error. So what to say about machines?
Okay,
Right.
Thank you so much, sir. Thank you. I would now like to request Professor Huda, sir, to kindly present a certificate to Professor Swagatam Das, sir, as a token of remembrance. Please, sir.
Thank you so much, Dr. Swagatam. The topic is so ever evolving, so complex, so difficult in terms of particularly the mathematical models to be used, and finally go ahead with predictive analytics and other form of analytics. But you have simplified in such a manner that almost even a person not having the background of computer science must have learned today that why machine learning and artificial intelligence in general is so popular even in social sciences and humanities and other subjects. So thank you so much for explaining this and enlightening all of us. This certificate is not for the purpose of certification, rather for the purpose of remembrance to you, as and when you see that you have been part of this wonderful and an outstanding webinar full of information for all of us on such an important topic. And that's how I keep on saying that the challenges ahead are very high, and the purpose of all these webinars are to ensure that we are enlightened with the knowledge. We are brought into a knowledge arena from the darkness. We are brought into the informed domain from blindness. We are brought into a kind of more informed domain, and that's how a great poet has simulated it, because we have been talking about simulating machines, simulating behavior. So the poet has said that उजाले अपनी आंखों में महफूज कर लो, means keep power of knowledge as integral part of our personality, irrespective of the domain in which we are working, because this knowledge will alone help us to face and deal with the challenges which otherwise we will be facing in our personal and professional world. So the poet has simulated it that उजाले अपनी आंखों में महफूज कर लो, बड़ी दूर तक रात ही रात होगी, means challenges बहुत होंगे, मुसाफिर हो तुम भी, मुसाफिर हैं हम भी, किसी मोड़ पे फिर मुलाकात होगी. Thank you so much, Dr. Swagatam. We'll meet again, once again.
Thank you very much. I hope we will meet next time in person.
Sure.
Things will get to
Sure. Sure.
Thank you. Updated to all of you.
Sure.
Bye-bye.
Sure.
Thank you, sir.
so much.
I would
Thank you
now
so much.
I would now
Thank you,
like to
Professor Das.
call
Thank you,
upon
Swagatam.
and take the
Bye.
Thank you, Professor Panigrai. Thank you.
Yeah.
And thank you
Yeah.
so much, my friend, Professor Panigari, for
Thank
connecting
you,
me
Professor
with
Hoda,
Dr.
and
Swagatam.
yeah, Professor Subrata,
Ji, thank
for
you.
this
Thank you.
initiative. Thanks a lot. Yeah. Yeah. Bye.
Thank you so much, sir. Thank you, all of you, all the dignitaries. I would now like to take the opportunity to call Dr. Ritika Vasan, ma'am, to please share formal vote of thanks. Please, ma'am.
Thank you, Ayushi ma'am. With this, I would first of all like to I'll take this privilege to thank Professor Swagatam Das to have delivered this wonderful session today. The simplicity with which he has explained the integrities of machine learning algorithms, I'm sure it has raised the inquisitiveness of all the attendees that we have had today. I thank you once again for this wonderful session. I'll also thank our distinguished panelist, Professor B.K. Panigrahi, for have connecting us to Dasa. I would also like to thank Professor Subrata Mukhopadhyay sir, who has constantly been supporting us and motivating us in all our webinar series up till now. With this, I also thank all our distinguished panelists and attendees who join us in all our webinars without failure. So thank you all of you for supporting us in all our endeavors. Thank you once again. Over to you, Ayushi ma'am.
So much, ma'am. Thank you, all the distinguished panelists and participants all through the webinar. A big thank you for joining us on this auspicious day. Thank you so much.
So
Dear
now the
participants,
meeting room is converted